You're standing on the deck of a ship in the Western Pacific. The water beneath you is the deepest on Earth, almost 11 kilometers straight down. And here is the strange part. Right now, at this moment, we have sharper pictures of the surface of Mars than we have of whatever is under your feet. Not a little sharper, not marginally. We can pick out a boulder the size of a desk on another planet, and we do not reliably know the shape of the ground beneath this ship. As of 2025, roughly 27% of the ocean floor has been mapped at modern resolution, 27. Meanwhile, a mosaic stitched together from 110,000 orbital photographs covers 99.5% of Mars at 5 meters per pixel. A planet 225 million kilometers away is essentially fully surveyed. The thing covering 71% of our own world is 3/4 unknown. The natural assumption is that this is about priorities, that we simply found space more exciting and pointed our money upward. But that isn't it. By the end of this, you'll understand that the ocean floor isn't unmapped because we didn't care. It's unmapped because it is genuinely, physically harder to see than another planet. And the reason is something you already know, but have probably never followed all the way to its conclusion. Everything we use to see across a distance is electromagnetic. Visible light, radar, infrared, all the same phenomenon at different energies. In the vacuum of space, this works beautifully. A signal leaves a spacecraft, bounces off Mars, comes back, and nothing along the way interferes with it. Water destroys all of it. Seawater absorbs and scatters electromagnetic radiation so aggressively that even the friendliest wavelengths give up within a few hundred meters. Radar, which mapped the entire surface of Venus straight through its clouds, cannot see through a swimming pool. Which leaves exactly one tool: sound. Sound travels through water beautifully, for kilometers, which is why every seafloor map ever made was made with sonar. But sound comes with a condition attached, and that condition is the entire problem. You cannot do it from orbit. The transducer has to be in the water. Something physical has to be there, touching the ocean, in that exact spot, to learn anything at all about the ground below it. So picture what mapping the seafloor actually requires. A ship dragging its sonar fan across the surface, painting a strip of seabed maybe a few kilometers wide, moving at roughly the speed of a bicycle. Now do that for 361 million square kilometers of ocean. It is the difference between photographing a country from an aeroplane and surveying it on foot with a tape measure. We mapped Mars by looking at it. We have to map the ocean by going there. And unlike Mars, the ocean actively destroys the things we send into it. At the bottom of Challenger Deep, the pressure is around 1,100 atmospheres, roughly 16,000 pounds, bearing down on every square inch. That is close to the weight of 50 jumbo jets stacked on something the size of your palm. Space is a vacuum. It pulls gently outward on a spacecraft, and a few millimeters of aluminium will hold it. The deep ocean crushes inward with a force that turns steel into foil, which is why the visitor numbers look the way they do. More than 700 people have been to space. By 2022, 27 had reached the deepest point in the ocean. We have kept a station permanently crewed in orbit for over 2 decades. We have never had one on the ocean floor. The hardest place for a human being to reach is not somewhere out there. It is about 11 kilometers beneath the Pacific. And yet the little we have seen down there has already rewritten biology. Entire ecosystems running on chemistry instead of sunlight, clustered around volcanic vents nobody had predicted existed. Mountain ranges longer than anything on land. Creatures that by every reasonable expectation should not be viable at those pressures, and are. Every serious mapping expedition turns up something unaccounted for. Not occasionally, routinely. And this matters well beyond curiosity. The shape of the seafloor determines how a tsunami travels and where it comes ashore. It drives the deep currents that move heat around the planet and set the climate. It hides tectonic faults nobody has cataloged. We are running climate models and tsunami warnings on a map of the ocean floor that is, across most of its area, an educated guess derived from satellite gravity measurements, accurate to about 5 kilometers. 5 kilometers. You could hide a mountain range in that. There is a project trying to fix exactly this. Seabed 2030 aims to have the entire ocean floor mapped to modern standards by the end of the decade, pooling data from research vessels, navies, and commercial shipping worldwide. It has taken the coordinated output of the entire seagoing world to move that number from around 6% to 27%. and it is not obvious that they are going to make it. So here is where all of that leaves us. We built our instruments for the sky because the sky let us look. Vacuum is transparent. That is the whole reason astronomy is an ancient science and oceanography is not. We have always been able to see upward. We have never been able to see down. The map of Mars isn't evidence that we cared more about Mars. It is evidence that Mars was visible and that the bottom of our own planet never has been. So go back to that ship in the Pacific. 11 kilometers of water underneath it, and a sonar beam painting a strip a few kilometers wide as it crawls slowly forward. Everything outside that strip is still, in the most literal sense of the word, uncharted. We named this planet Earth after the ground. We have never actually seen most of it. What do you think is down there that we haven't found yet? Let me know in the comments. New discoveries unlocked daily. Subscribe so you never miss one.